Good morning, team. Today is Thursday, May 7th, 2020, and we are finally in our last unit of the year. We're going to wrap up the year with some review. Yesterday, you reviewed balanced and unbalanced forces with Miss Janice, and today we're going to take another look at Newton's laws. If you haven't completed your Hello Morning survey, please stop, pause the video, and go complete your Hello Morning survey. Thanks, team. Let's jump into our science and COVID-19 fact of the day. So, University of Arizona biological anthropologist and comparative psychologist Evan McLean, his research states that dogs may provide welcome emotional support during the pandemic. So this is a picture of the image that was with the article that says during self-quarantine, dogs may help protect mental health. This is actually something that has been researched for a while. There are known psychological benefits to owning a pet. I found this really cool video of a dog that was trained to deliver groceries to a quarantine neighbor. So let's check it out.
Tuning Out the News, the first animated series to cover the news the same day it happens, featuring hard-hitting news shows.
The story's undercooked. We won't send it back to the kitchen. It's rude.
Tuning Out the News, now streaming only on CBS All Access.
She got the list, she gave it to Sonny, Sonny brought it to me, I went to the store, got her her groceries, and he delivered them all to her.
What a wonderful thing, just a sweet thing. So we started doing the schlepping back and forth, and it's been fun. It's been a real treat. Little things like Sonny coming over to visit is nice, and it makes you feel good, and it's a way of communicating.
Anybody can do something so small that could be so helpful.
Okay, so now it's your turn. I want to know, do you have a pet at home? Do you feel like your pet is helping you cope during this stressful time? If so, I want you to comment and then send me a picture of you and your pet, and maybe I could put together a little slideshow of everyone with their pets. So go to this post in Google Classroom and answer the question, do you have a pet? If so, do you feel like your pet is helping you cope during this stressful time? Go. Great. Let's jump into our science lesson for today. Today we're going to review Newton's laws. You are going to be able to differentiate or tell the difference between Newton's laws of motion and explain how Newton's laws impact the motion of everyday objects. So, Newton's first law is the law of inertia. This states that an object at rest will remain at rest unless it's acted on by an unbalanced force. An object in motion will continue with constant speed and direction until it's acted on by an unbalanced force. What is inertia? Inertia is the resistance of an object to a change in motion. So if we remember the seatbelt example, okay, you're riding along in your car, the seatbelt is strapped you in. So this is like one unit right here in motion. You slam on the brakes, but because your body was in motion, it's going to continue in motion until it's acted on by an unbalanced force, which in this case will be the seatbelt. Let's take a look at Newton's second law. Oh, sorry. Let's look at an example. So here's an example problem. You're riding in a vehicle with a coffee cup on the dashboard while traveling 30 kilometers per hour. The vehicle makes a sudden stop to avoid hitting the car that has stopped in front of it. So here I have a picture of a cup of coffee on a dashboard. Which illustration best demonstrates what would happen to the coffee cup? So let's pick out our keywords here. You're riding in a vehicle with a coffee cup on the dashboard. Okay, this is important because that's where it's sitting. They give you the unit here that you're traveling, your speed, but this is not really that important, okay? What is important is that the vehicle makes a sudden stop. So this is going to be an unbalanced force on the brakes, which will stop the car, okay? But what's going to happen to this cup of coffee? So let's look at our answer choices. Answer A, will the cup of coffee go forward? If this were the case, then the coffee would continue in the same motion that it was in before. That kind of sounds like it matches Newton's laws, but let's look at our other options. Would it go backwards? So if it goes backwards, it would move in the opposite direction of the motion. So that doesn't seem right. I'm just going to get an X here really quickly. So I'm going to X out that answer. Will it stay stationary? So if it stayed stationary, this would mean that it would resist it would not move even when the brakes are applied. Now we know that that's not the case because we've been in cars before with things that moved after we applied the brakes. So let's see here. Would it go straight up? In order for it to go straight up, then that would mean that there would have to be a force that would lift the cup up that would be stronger than gravity. Okay, in this example, we don't have any examples of lift, so we know that that one is not correct. So our answer is A, the cup would actually go forward, okay, because this is the motion that was already occurring before the brakes were hit, okay? Let's check out Newton's second law. Newton's second law is the law of acceleration. This is our formula, okay? F equals ma. So here we see something with greater mass is going to require greater force. So changing an object's speed and direction depends upon the mass of the object and the amount of force exerted on it. Remember, a force is a push or a pull, okay? A greater force, same mass, will mean greater acceleration for the smaller object. Same force, greater mass will be less acceleration, okay? So I use the example of having two small balls that you kick. I'm sorry, let me go back. Not two small balls. Let's say you have a bowling ball and a soccer ball. If you try to kick the bowling ball, it's not going to go as far because it has greater mass. Now let's look at an example. 4 boxes are sliding with constant speed before each box experiences an unbalanced force of 8 newtons. Which box would experience the greatest acceleration when the unbalanced force is applied? So I already put a text box here. I'm going to think through this. What parts of this question are really important? These 4 boxes are sliding with a constant speed. They experience an unbalanced force. So that means that there's going to be a change. An unbalanced force will result in a change in motion. Okay? The question is asking me which box will accelerate the most. Now, I know from my law that the force is equal to the mass times acceleration, and I know that the smallest mass equals the greatest acceleration. So what I need to do is look at my answer choices and look for the answer that has the smallest mass. So here I have a box with 2 kilograms, a box of 4 kilograms, a box of 6 kilograms, and a box of 8 kilograms. So I know that my answer is going to be, I'm going to go back here and get one of these X's really quick. I know that my answer is, going to be the first one because that is the box with the smallest mass. So that box is going to experience the greatest acceleration. So my answer is F. Now let's look at the third law. This is the law of action and reaction. So this states that for every action, there's an equal and opposite reaction. So here we have a gun. The recoil force of the gun is going to go backwards with the same amount of force as the force of the bullet going forward, okay? Here we have a person walking. The action force is that your foot is pushing down and back on the floor. The reaction is that the floor is actually pushing up and forward towards you, okay? Here we have a boy on a boat. So the action is that his feet are exerting a force on the boat. The reaction is that the boat is exerting a force back onto the foot. Let's look at an example. A student jumps off of a sled toward the west, over here, after it stops at the bottom of an icy hill. Based on the law of action and reaction, in which direction will the slide most likely move as the student jumps off? So I have my text box here. I'm going to say, we know that in action-reaction, the forces are equal and opposite. So what I need to do is ask myself, which direction is opposite of the action force? The action force is the student jumping off to the west. So I know that the reaction will be to the east. So the sled will move to the east. I'm going to go back and get one of my X's. I know that the reaction force is going to be opposite, so I know that my answer is C for the east. Now, when I say go, you're going to go to the next section of this Google form. I've recorded 3 real-life examples of Newton's laws. 2 of them are actually my kids. You're going to watch these video demonstrations, and then you're going to answer 2 multiple choice questions. You're going to repeat that for each of Newton's laws. So there are 3 sections with 2 questions in them, 1 for each law. At the end, you're going to need to create your own real-life example of any one of the Newton's laws. So you're going to need to tell me which Newton's law it is and give me the example. After that, you're going to turn it in Google Classroom. If you have any questions, of course, email me or call me. And I miss you guys so much. I can't wait to see the real-life examples that you come up with for Newton's laws. Have a great day, team.